In this video, we're still going to talk about probability, percentages. We want to use the phrase conditional probability. And instead of memorizing a formula, which if you Google conditional probability, you might see a formula. But we're going to take a non-formulaic approach just to consider what a conditional probability calculation looks like. And to be honest with you, we've already, if you've completed the other videos in this module, you've already done some of these calculations. It's now just putting some formality to it. So let's just recall very quickly, probability in general is the same as a percent, just as a decimal. So we are given a survey here of faculty and students, asked how many children they have, and we want to calculate the probability of randomly selecting a faculty member from this group. So the probability, and maybe I want to circle the items that I'm considering here, the probability of randomly selecting a faculty member. With the formal notation, this would look like, what's the probability of randomly selecting faculty? And this is actually good. We're getting into the notation a little bit. So the probability of, I'm going to put that in parentheses, faculty is, well, the total number of people in this survey was 81, and the total number of faculty in this survey were 33. So there are 33 out of 81 people were faculty, and when I find that decimal, I get approximately 0.4074. So we have a probability of about 0.474, a little bit less than half. We know half would be 0.5. If I asked you to turn this into a percent, it would just be 40.74%. So a probability and percent, they go hand in hand. So 40.74% of people in the survey were faculty. But as a probability, the probability of randomly selecting a faculty member is about 0.4074. The probability of selecting a student that has one child. Now, the language here can be really tricky. Some of the problems previously, we looked at all of, we compared red hair and glasses. Here, we're looking at not all of the students and just focusing on the students. And then out of that group, how many or what percent has one child. We want to know the probability that an individual is a student and has one child. And so I'm actually thinking about the 81 people. Out of the 81 people in this little survey, how many of them are a student with one child? Because that would be then the probability of selecting them from this group. So on this table, here is my student row. I see there are 48 total students. And out of this 48, it looks like 10 of them. So this value, there are 10 students with one child. So there are 10 people who meet this criteria out of 81. And as a probability, we get this is approximately, that's fun, 0.1234. And that continues. And this actually would round up to a 1235. So we get a probability of a 0.1235. If I asked you to write that as a percent, there are about 12.35% of people are students with one child. Where this becomes more complicated is when we start to see a little bit different notation. And down below here, I have what's called conditional probabilities. This is just some notation to introduce the concept of conditional. And I think what can be helpful is just to, instead of just jumping right to the calculation and memorizing a formula, let's write out what exactly this language or these formats here, notation, what it's saying. So we're going to interpret, write it out in words, and then we're going to calculate. So when you have the probability and you have this line here in the middle, this is saying calculate the probability of someone having 0 children given, this line means given they're a student. So this says calculate the probability of, selecting 0, which in this case is 0 children. And then that lines, it means given, or based on the fact that they are a student. Given that they are a student. As soon as you see that line, all right, that tells you that the next thing you're going to see, you want to focus just on that subgroup. So we want to calculate the probability of selecting 0 children or someone with 0 children given that they're a student. That means we're going to focus on just the students. And so we need to find all students, just the students. That's our condition in this case. So out of all students, how many of them have 0 children? So our numerator will be 0 children and a student, because those are the individuals who are students and have 0 children. And it's conditioned on or based on focusing on just those who are students. So when I look at this table, I see there are a total of 48 students. So that is the condition here. Given that they're a student, well, there's 48 of those individuals. And out of the given that they're a student, 18 of them have 0 children. So the probability of selecting someone with 0 children, given that they're a student, well, 18 out of 48, if we calculate that as a probability, that probability is exactly equal to 0.375. If I asked as a percent, this says 37.5% of students have 0 children. So again, that line in this work here, in this notation, is just saying given, and it's going to narrow our attention to all students. So in this next one, if we wrote this out in words, what's the probability of selecting a faculty member? So we want to find the probability of selecting faculty given, or just focusing, given that, or given, we'll put it this way, given those with 2 or more children. So as soon as we see that line given, that means this group is the subgroup we're going to focus on. We want to focus on all of those people with 2 or more children. So given that, we know that we're selecting from those with 2 or more children. And then out of those with 2 or more children, how many of them are faculty? So in this particular survey, we see there are 39 total people with 2 or more. That's the condition. That's our criteria that needs to be met. We're focusing just on that total. And out of those individuals, 19 of them are faculty. So 19 people out of 39 gives me a probability of, let me change my color, 0.4872. And I'm rounding that out to the 4 decimal places. So we get a probability of about 0.4872. That means almost 50%. So this is about 48.72% of those with 2 kids are faculty. So again, this language, this notation is a little bit different. We've already done these calculations. It's just writing it a bit different. It is using this line to indicate given, or such that we're focusing on a subgroup. So the first one we were focusing on all students, given that they were a student. And the second one, we're focusing on those with 2 or more children.